Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So in this video, we are going to learn about sampling distribution. This is the topic outline for this chapter. First is the introduction. Next is the central limit theorem. Then you will learn about 4 types of sampling distribution. The first one is the mean, the difference of two means, sampling distribution for proportion, and the last one is the sampling distribution for the difference of two proportions. So we begin this chapter by reviewing the terms population and sample. So this population consists of the total of observation which we are concerned. If, for example, we want to know the height of students in UTM Kuala Lumpur, or you want to know the income of staff in Bank Negara. Okay, so from this population, we can get the parameter, which is the mean mu for parameter, population parameter, sigma square is for variance and proportion. So from this population, we select a random sample to get the information about the unknown population parameters. Okay, so instead of counting the height of every student in UTM KL, so we take the sample and we get the mean of the sample, okay, the variance and sample proportion. So all these parameters is called statistics. Statistic is the parameters from the sample. So the value of mean that we get is used to make an inference, okay, concerning the true mean height of a student from UTM-KL. Okay, so since many random samples are possible from the same population, thus the mean, okay, or the other statistic parameter are expected to be vary from sample to sample. So statistic is any function of the observation in a random sample. For example, we have a sample mean, a sample variance, and sample standard deviation. Okay, so what is sampling distribution? So the sampling distribution is the probability distribution of a statistic, which is called as sampling distribution. For example, here we have three weight of a pack of rice. Okay, we have 10 kilos, 20 kilos, and 30 kilos. So from this population, okay, here we have our mean, given that we can just find the average of the weight of the pack of rice, given that it is 10 plus 20 plus 30 over 3. But let's say we have to pick two pack of rice from this population. Okay, so this is the outcome of the events that we get, okay, which is the weight of the pig. Let's say for the first event that we get is 10 kilos and 10 kilos, and then the second one is 10 kilos, 20 kilos, 10 kilos, and 30 kilos, okay, and so on, okay, up until 30 and 30 kilos. So these are the outcome of getting two bag of rice, okay, and then here we can count the mean of this sample. Okay, given that the mean of this would be 10 plus 10, which divide by 2, which is equals to 10. 10 plus 20 divide by 2, which is equals to 15. So all this column shows the mean of the sample. So from this table, we can make the sampling distribution of mean, okay, with sample size of 2, given that sample size of 2 is the number of pack, okay, the rice pack that we choose. Okay, so here we have a list of mean, given that it starts from 10 and we have mean of 15, 20, 25 and 30. So for 10 kilos, mean of 10 kilos would be equals to only one outcome from here out of 9 outcomes. Okay, so it will be 1 over 9. Meanwhile, for 15 kilos, it will be 1, 2. 2 outcomes out of 9. Okay, and for 20, we have 1, 2, 3. 3 over 9. 25 would be 1, 2, 2 out of 9. And the last one is 30 kilos, which is 1 over 9. So from here, this is what we call as the sampling distribution of mean. Okay, given that the sample size of 2. Okay, so in this chapter, we will learn two types of sampling distribution. The main sampling distribution is on the sampling distribution of mean, and the second one is the sampling distribution of proportion. So inside here, we also will learn the difference of the mean, okay, the sampling distribution of the two different mean, and sampling distribution of two different proportion. So before we go through the sampling distribution of mean and proportion, let us get to know what is central limit theorem. So the central limit theorem is when the original variable is normally distributed. So the distribution of the sample means will also be normally distributed for any sample size of n. But when the distribution of the original variable might not be normal, so a sample size of 30 or more is needed, okay, to use a normal distribution to approximate the distribution of the sample mean. So the larger the sample, the better the approximation will be. So more precisely, the central limit theorem states that, okay, the mean of the sampling distribution of means is the same as the population mean. Second one is the variance of the sampling distribution of means is the same as the population variance divided by the size of sample. And the third one is if the population from which the sample was taken is normally distributed, then the sampling distribution of means will also be normal. But if the population is not normally distributed, then the sampling distribution of means will approximately be normal distributed as the sample size gets larger, usually when n is greater than or equals to 30. So that is about central limit theorem. So the first important sampling distribution to be considered is that of the mean, x bar. So the sampling distribution of mean is the distribution of sample means, okay, where this sample mean may be different from one sample to the next one. Okay, so here the sample is obtained from an experiment conducted over and over on different samples on the same size. So this is the example, okay, that I gave you earlier, where you choose two sample size of pack of rice. Okay, so the outcome of the mean from the sample would be 10, 15 up until 30. And here is the sampling distribution of the mean. In sampling distribution, we have two cases, okay, where the first cases, let's say we have, okay, a random sample of an observation taken from the population that is normally distributed. given that the population has mean mu and the variance sigma square. So each observation in the random sample will then have the same normal distribution as the population being sampled. Thus, the expected mean of x bar of the sample mean will be given as mu of sample mean equals to the mean. Okay, so this is the mean, which is the mean from the population. Okay, and the variance of the sample mean would be equals to sigma square over n, given that the sigma square is obtained from the population. So now we can write the distribution for the sample mean, which is given that x bar follows normal, given mean is the population mean, and the variance would be sigma square over n. And the standardized variable, given that z equals to x bar minus mean divided by the standard deviation, given that it is sigma over square root of n, follows a standard normal distribution. And now this is for case 2. If we are sampling from a population with unknown distribution, okay, or it is not normally distributed, so the sampling distribution of mean will still be approximately normal with mean mu and variance sigma square over n, okay, provided that the sample is very large, okay, where the sample should be n greater than or equals to 30. So if the population distribution is unknown or not normal, then using the central limit theorem, so now the sampling distribution for sample mean is normally distributed when n is greater than or equals to 30. So for your note that the continuity correction factor is not needed for random variable of x. Let's try the first example. A light bulb manufacturer claims that the lifespan of its light bulbs has a mean of 54 months and a standard deviation of 6 months. Okay, and your consumer advocacy group tests 50 of them. So here is our n, given that our mu is 54 and standard deviation is equals to 6 months. So this is our parameters for the population. Okay, assuming the manufacturer claims are true and it follows the normal distribution. So for this case, we can write our x, given x is the number of lifetime of the light bulbs, okay, where the population follows normal. So for this case, it will be 54, the mean, and also the variance will be 6 square. So this is for the population, the distribution of the population. Okay, but here we test 50 of them, given n is equals to 50, and it follows the normal distribution. What is the probability that it finds a mean lifetime of less than 52 months? Meaning that we want to find the sample mean less than 52 months. So here we have our sample taken, which is 50. So we want to know what is the distribution for this sample mean. So remember that I show you the expected mean for the expected value, okay, or mean of the sample mean, sampling distribution, will be equals to mean of population. So the mean here would be also 54. Okay, and the variance for this sample mean would be the variance of the population over n, okay, over sample size. So it will be 6 squared over 50. So here we can write the normal distribution for the uh, sample mean, which follows normal. Given mean is 54 and the variance is 6 squared over 50. So here our main is to find the probability of mean lifetime. So we have to use this distribution. Okay, so now the probability we have to find using the standard normal distribution for this case. Okay, so here would be x bar minus 54 divided by the standard deviation, which is 6 over square root of 50 less than 52. So I just rewrite whatever variable given in this bracket. So 52 minus 54 divided by 6 over square root of 50, which is equals to the probability of z less than negative 2.36. So if we draw the area of this, it will be this one. So we can just straight away get the value from the book, which is equals to 0.0091. So the probability that the mean lifetime less than 52 months is given 0.0091. Now let's try another example. The average life of a washing machine is 12 years with a standard deviation of 2 years. Assuming that the life of these machines follow approximately a normal distribution, find the probability that the mean life of a random sample of 12 machines is greater than 10 years. And then need to find the probability of the mean life of a random sample of 9 machines fall between 9.4 and 12.2 years. So here we have the average life, 12 years. So given that this is mean of the population and the standard deviation of 2 years, sigma will be equals to 2, which follows approximately a normal distribution. So this random variable x follows normal given that the mean is 12 and the variance is 2 square. So we want to find the probability that a mean life of a random sample. So we choose sample of 12 machines given our n is equals to 12. So since this is a sample, so the sampling distribution for the mean would follow normal given that the mean is the population mean and the variance would be the variance of the population over n. So now we want to find the probability that the mean will be x bar greater than 10 years. So using the standard normal distribution, this would be x bar minus 12 over 2 over square root of 12 greater than 10 over 2 over square root of 12, which is equals to z greater than negative 3.46. So using the table, okay, which means that we have to find the area of greater than 3.56. From the table, meaning that you have to find 1 minus the probability of z less than negative 3.46, which is equals to 1 minus 0.0003, which is 0.9997. Now we solve for B. Given that the probability that the mean life of a random sample of 9 machines. So here we have n equals to 9. So the distribution, now we change x bar follows normal. Given the mean is 12, but the variance now is 2 square over n, which is 9. So we want to find the probability of the mean life between 9.4 and 12.2. So here would be 9.4 minus with mean divided by the standard deviation 2 over 30. Is equal to the probability of negative 3.9 and 0.3. So the area covers here, which means that you have to find the probability of Z less than equals to 0.3 minus with the probability of Z less than equals to 3.9, negative 3.9. Okay, now you can try out this. Given that the random sample is taken from a population which is distributed Poisson 10. So what is the probability that the sample mean is larger than 12 and the sample mean is between 11 and 13? So here this is the Poisson distribution given lambda is equals to 10. So from here we know that mean is equals to lambda, which is equals to 10, and also the variance is also equals to 10. So we can write that our x follows normal given the mean is 10 and the variance is 10. So taken that the random sample of size 100, which means that our n is equals to 100. So now the sampling distribution of mean, the distribution of mean would be n follows 10 given that the variance is 10 over 100. So we can find the sample mean, the probability that the sample mean is larger than 12. So we want to find the sample mean is larger than 12, which is can find using the standard normal distribution greater than 12 minus with mean divided by the standard deviation square root of 10 over 100. Which is Z greater than 6.32, which is equals to 0. Okay, which means that it is impossible to get the sample mean that is larger than 12. So now we try to solve B. So I just rewrite back the distribution. So we want to find the sample mean between 11 and 13. So we transform this to the standard normal distribution over square root of 10 over 100 z. So we want to find the area between this, which means that we have to find the probability of z less than 9.49 minus with probability of z less than 3.16. So it will be 1 minus 3.16 is given as 0.9992, which is equal to 0.0008. Now let's try the last example, a random sample size of 35. So here we have sample size is taken from a population. So our population has normal distribution as follows: binomial with the number of trials 50. So this is number of trials given that our n is equals to 50. And the proportion of success 0.3. So the proportion of success given as P is equals to 0.3, and 1 minus P would be equals to 0.7. So our aim is to find the probability that the sample mean is at least 13.5. So first let us find this binomial distribution. So x follows binomial given it is NP. So here would be x follows binomial given n is 50. So don't confuse with the sample size of 35. Okay, so n here refers to the sample size, but n equals to 50 is the number of trials in the population. So it's different. Okay, and then 50 comma with p, which is 0.3. So since our number of trial n equals to 50 is greater than 35, 30, so our NP is equals to 50 times with P 0.3 is equals to 15, which is greater than 5. Okay, and for NP times with 1 minus P is equals to 10.5, which is also greater than 5. So we can use the normal approximation for this binomial distribution. So given that this follows normal, NP comma NP times with 1 minus P. So our NP is given as 15, and NP times with 1 minus P is 10.5. So given x follows normal distribution with mean is 15 and 10.5. So now our main concern is that we want to find the sample mean. okay, at least 13.5. So we have to change this distribution to the mean distribution. So given that we choose a sample size of 35, so n of the sample size is given as 35. So here would be in terms of normal distribution 15, 10.5 over 35. So now we can find the probability of X bar at least 13.5, meaning that we have to find greater than equals to 13.5, which is equals to the probability of Z greater than equals to 13.5 minus 15 divided by the square root of 10.5 over 35. So we will get the probability of Z greater than equals to negative 2.74. So the area covers would be this one, which means that we have to find 1 minus probability of Z less than negative 2.74, and you will get 0.9969. Now let's learn about the sampling distribution of two different sample means. Suppose that we have two populations, x1 and x2, which are normally distributed. So this is the parameters for x1 given that we have the mean mu1 and variance sigma 1 square. So the distribution of this x1 can be written as this, follows normal mean 1 sigma 1 square, and then we have the sample mean from this population x1. So x1 bar represents the mean of a random variable of size n1 selected from the population x1. So the distribution for this will be the sample mean of x1 given follows normal distribution, with mean is the mean from the population of x1, and the variance is sigma 1 square over n1. And this is the population from x2. So the mean is mean 2 and variance is sigma 2 square, and the distribution follows normal given mean is mean 2 and the variance is the variance from the population x2. So if we choose a sample size of n2 selected from the population x2, so the mean 2 represent the mean of a random variable of size n2 selected from the population x2. So the sample mean of x2 follows normal given that the mean is taken from the mean of x2 and the variance is sigma 2 square over n2. Now we are interested in finding out what is the sampling distribution of the difference between two samples mean, x1 minus x2. So the mean of these two different samples, x1 minus x2, is given as mu1 minus mu2. Okay, given that this mean is obtained from the first population and the second population, and the variance of the difference between two sample means will be given as sigma 1 square over n1 plus with sigma 2 square over n2. So now the distribution of the difference between two sample mean would follows normal given the mean is mu1 minus mu2 and the variance is sigma 1 square over n1 plus sigma 2 square over n2. Hence, we can use the standard normal distribution given that the difference of two sample mean minus with mean 1 minus mean 2 over the square root of variance. So now let's try this example. A consumer of an electronics company is comparing the brightness of two different types of picture tubes for use in their television sets. So we have type A tube, which has mean brightness of 100 and standard deviation of 16. So for this one, this is the mean for A and this is the standard deviation for A. And for the type B, it has mean brightness of 110 and standard deviation of 14. And a random sample of 36 tubes from each type. So NA is equals to 36. Same goes for NB, sample size is 36. So what is the probability that the difference of two sample mean B minus sample mean A is at least 8.5? So this follows normal distribution. So here we can find the x bar A follows normal given the mean is 100 and the variance would be 16 square over 36, and for the sample mean from B type B would follow normal given the mean is 110 and the variance would be 14 square over 36. So our main objective is to find the probability that the difference of two mean here is at least 8.5. So now, before we find this probability, what we need to do is we have to find the distribution, okay, the value of mean and the variance for these two difference of sample mean. So given the sample difference of sample mean xb minus xa follows normal, given the mean for these two different sample mean is given as the mean b minus with mean a, and the variance would be sigma square of a over n plus with sigma square b over nb. So given that this is equals to MB is 110 minus with 100 and the variance would be 16 square over 36 plus with 14 square over 36. So the distribution of this different sample mean would be 10, 12.56. So now we can find the probability of sample mean B minus with sample mean A greater than 8.5. So using the standard normal distribution, which will be Z, or I can just rewrite this as XB minus XA minus with the mean over the square root of 12.56. So here would be Z greater than negative 0.42, which is equals to so we have to find 1 minus probability of z less than negative 0.42. Okay, now you can try example 2 and example 3. Okay, pause the video and you can check your solution after this.